Tomorrow we drop.
Oh, all right. Well, then we'll get through what we can today. So the first thing I want everybody to do is open up Google Sheets. It's on your iPad. I'm going to be doing it on my iPad so that we all have exactly the same features. It's actually a little bit more full featured if you do it on the computer, but we get a lot of options here. So here's what we're going to do. We're going to do some calculations for a free falling object. All right. And we're going to let Google Sheets do some calculations for us. Then we'll look at, basically, we're going to figure out where it's located and how fast it's going and all that from some of our physics equations. But then we'll also do calculations about what kind of kinetic energy and potential energy we have. So we're first going to imagine this free falling object as something that, you know, I've done in class a few times. You know, hold something up at 2 meters, so just a little bit above your head, and let it go. So we're going to drop this thing from free fall, from rest, starting at 2 meters. So I'm going to wait just a second. Does everybody have a Google Sheet open in front of you? You're going to have to do this along with me. Okay. I'm not hearing anything, so I'm assuming you guys are good to go. So the first column, we're going to set up, let's do time for the first column. And we're going to measure time in seconds. And just to make things easy, I'm going to, underneath each heading, I'm going to put just like the letter of the variable that we usually use. And I'm going to do that because later on in some of the columns, we're going to actually write out the formula so that we know what's going into the calculations. So for this, our first row of data, time at the start of this, is going to be time equals 0. And then the next thing that we want is our height. And we're going to measure that in meters. And we got a few things we could put in here. And I'm not particular about it. We could put in H for height. We could put in Y, right? Because height is in a Y direction. So it's our choice. For now, let's just use H. I want this to be a lowercase h, but it's not, doesn't seem to be letting me put it lowercase in. There we go. All right. And if our starting height is 2 meters, we'll just put that in the first box. 2. Okay. So now we need a row for how does this height change, right? This is our location. How does our height change? Like if we move forward in time. So if our time goes from 0 to 1 second or 0 to 0.1 seconds or 0 to, you know, whatever time increment we decide. Now, if I'm dropping something from over my head, it's only going to take, I don't know, about a second to get to the ground. So we want a smaller time chunk than just 1 second, right? If it takes 1 second, we'd only have one row of data. So let's put in 0.1, then I'm going to go 0.2, 0.3. And I think on the computer, this is pretty easy. You just like click on a box or highlight a set of boxes like this. And then you'd usually grab the bottom corner and drag it down. I don't think I can do that here, but I think if I drag a big box and if I say autofill, you see if you highlight that area and then click autofill, it should see that same pattern and continue it for us. So that's nice. I don't have to type in that number every time. Just by putting, about 3 or 4 boxes, it is able to be smart enough to see that pattern and then fill in the rest. So now, where is this going to be 1/10 of a second later? We need to do some math. What's important here? We need to know what our acceleration is. Now, we know it's 9.81, right? So we can actually, add that into our formula, but maybe this is a little bit redundant, but I'm actually going to give this a column, acceleration. And this is in meters per second squared. Since we can't write the squared on the keyboard, we just hold Shift-6 to do a little up arrow that tells us that the 2 is an exponent. Okay, and we know that we use the a variable. And I'm just going to say negative 9.81. And I'm going to type that in again, negative 9.81. And now I hope just with 2 boxes that I could autofill and it will see yes. So why did I put that same number in every time? Because acceleration is not changing. We're here on Earth. It's always accelerating the same way. Now, we want our location. We want to know where we are. We need a formula. We need a formula if we have an initial velocity and an acceleration, and we want to know where we're located. Any thoughts? Take a look at your reference table. Last page with all the kinematic stuff. Come on, somebody weigh in. I know somebody knows this. We have an initial velocity. We have an acceleration. Looks like we have a time. How do we figure out where we're located? Don't leave me sitting here all by myself. Come on, somebody, take a guess. We got some equations. Take a look at your reference table. Stop playing video games. Now you guys are making me nervous. Can you actually hear me?
Yeah, we can hear you.
All right, good. All right. So now answer. Take a guess. There's I don't know, 5 equations that we used for like our first unit, kinematic stuff. V equals d over t. We had acceleration as a change in velocity over time. We had v final equals v initial plus at. We're looking for one of those equations that has a distance in it, right? We're trying to figure out where we're going, a displacement.
V equals d over t.
Which one?
V equals d over t.
V equals d over t. That would be good for sure. The problem is we don't have, because we need the distance, right? But we don't have a velocity yet. So we're not ready to use that formula. And that V with a little line over it, that's an average velocity. So we definitely don't have an average velocity because this thing starts at rest and it gets faster and faster, and we'd have to figure something out to do that. It's possible, but we're not quite there. So that's one of them with a D in it. What's the other one? There's two more.
Is it maybe D equals V initial time plus half acceleration time squared?
Yeah, that's what we're going to use. Let's try that. So thank you very much. D equals, I'm going to say VIT. This is just for us so that we can, know what we're going to write in the equations below. So let's see, 1/2 AT squared. All right, so how can we do this? Well, our V initial is 0, right? I said we're starting from rest. So if I, in this box, type in V initial times T, that's going to be 0 always, right? So I actually kind of don't have to have that in my equation. And I can just add in the equals to tell it that I'm writing an equation. And now I'm going to just do 1/2. So actually, you know what? I'm going to write the whole thing out. I'm going to say equals VI is 0 times T. Now, how do I get T? All I have to do is touch on the box next to it. A4 is our time for this row. Plus 1/2, but I'm just going to simplify that for me to write it out as a 0.5. And now my acceleration, I'm going to say times acceleration, in this case is a box. I could have just typed it in, but since I have a column for this. And now I have to multiply it by time squared. So I have to raise it to the second power. I don't know if you could see, but at the bottom of my screen, I've kind of gone outside the box up top, but at the bottom of my screen, you can see that full equation. And I'm a little confused. If I started at 2 meters and now I'm at negative like 5 centimeters, what does that mean? Does that mean I've already, in 0.1 second, have I already gone like below my feet into the ground, a negative height?
Hey, Mr. Varney.
Yep.
How did you, after the plus 1/2, how did you get the other box?
Touching it. So sorry, let me, all right, can you see my screen here? Can you see what I'm typing?
Yeah.
Okay, so plus 0.5, right? And then what is the next thing? Acceleration, A, which is the column, the C column I have here. I just touch the box next to us, the C4, right? Which is negative 9.8.
Got it.
Okay, and make sure you, so I didn't say multiplication in these equations. You can't put an X. X is just the letter X. Multiplication is the asterisk, the little star, and you hold Shift 8 to get that. Okay, and so now I have acceleration, and then I have to say times. Now I have to touch time again, which is my A column, and then I have to hold Shift, press 6 to square that. All right, so there's my answer. You should all have this negative 0.04, which is approximately 5 centimeters. But that negative is telling me that I am below the 0 height. So something's off. I've messed something up. We're confusing a couple things right now. Can anybody tell me what I did or what we're mixing up?
Maybe that we're not squaring something.
Nope, actually the answer to the equation came out correct. So this is a negative 5 centimeter something, but what is this equation d equals VIT plus 1/2 AT squared? What does that equation tell us? What is d? I've been saying distance, but I've been misleading you. What is another thing that's kind of like distance?
Displacement.
Yeah, this is displacement. So this negative 5 centimeters is telling us we've gone down 5 centimeters, but we didn't factor in our starting point yet. So we need to go back into that equation where I have my negative 0.04. If you click on the box, I don't know, can I double click? Yeah, you can double tap on it, or you can touch the box, and in the bottom right corner, you can hit the pen to edit. And I forgot to take my starting point and then subtract my displacement. All right, so this is going to be a little tricky too. In the equation, I'm going to change where I'm editing, and I'm going to go right to the very beginning of this. And I want to take this whole thing and add it to where I started. So actually, this is the spot, oops. B3 is the spot that I've started. Now, does that make sense to everybody? Does everybody see what I'm doing here? I'm saying I start at 2 meters, and then I take this new answer, which is -5 or -5 centimeters, and I'm going to combine them. So 2 minus 5 centimeters, I should get an answer. There I am. I'm at 1.95 meters. That makes sense. I'm moving towards the floor. Questions or comments about that? Now, the next step of this is going to get tricky, so stick with me. Let's just take this and go down one box. I'm going to hit autofill. Here's the problem. Take a look at the equation here. B4 minus how much my displacement that I've done in 2 seconds, or 0.2 seconds. B4 is the previous step. Really what I need is this B4 shouldn't be B4. It should be that first 2 meter starting height. So I really want this to be B3. Right? That's my starting height, and I'm always subtracting how much displacement I have. But the problem is, every time I do this, the program says that first number, it doesn't know that I'm not supposed to move that. Looky here. It's still switched to B4. Every time I go to another row and copy, paste. So this is a spreadsheet trick. This is how, I'm teaching you a little bit about spreadsheets. B3, instead of just typing in B3, these are all relative to the box that I'm typing in. So the red numbers are the box to the left and the box to the right. The green is one above. But I really want B3 to never change. For every time I copy paste this equation below, it shouldn't change. So I put a $sign in front of the B and a $sign in front of the 3. When I hit enter, nothing changed for that calculation. But when I fill below, all of these other, let's just do 2 of them. They remain with B3. Look, the $sign B, the $sign 3 is still there. I go to the third point of data, $sign B, $sign 3. So now I've locked that number in the equation so that it's not constantly changing. It's always saying starting height of 2 meters. Now let's see. What happened here? 0.1 second, I've gone down about 5 centimeters. 0.2 seconds, I've gone down 20 centimeters, so on and so on. What's happening, Mr. Pena?
You laughing?
We're just teaching a little spreadsheet stuff for these guys. This is Regents Physics.
Oh, nice.
Yeah.
Very nice. Fabulous. I didn't know you were here. I would have stopped in early. I have my students working in groups right now.
Oh, very nice.
Day from home, breakout rooms. Glorious breakout rooms.
There you go. Enjoy. No, I wish. That'd be awesome.
Well done, sir. You're getting better.
That's yeah. That's an overseas. I mean, like shipped out order.
I gotcha.
Yeah.
Cool. All right, I'll get back to
All right, cool. All right. So somebody tell me why all of a sudden at 0.7 seconds, I'm at negative numbers. What's going on?
Is it accounting for like the bounce back?
Nope, it can't, because it's just doing what we told it, and we're just telling it, calculate a displacement, after, 1 second or 0.7 seconds. Or so this displacement has gone into the negatives because actually it's reached the floor in less than a second. It's reached the floor somewhere between 0.6 and 0.7 seconds. Anything below that, this program doesn't know that there's a floor there. So it's just going to do the math. And it's doing the math and basically telling us where it would be, if the floor wasn't actually there. So this would be the same thing if I dropped it out the window, right? So at 1 second after I let go, it's going to be about 3 meters below my feet. And that continues. So here's something kind of cool. What if I change the 2 at the beginning? Since this box wasn't an equation, I just typed in a 2. And since that 2 is used for all my other calculations, I could say, well, what happens if I drop something from not 2 meters, but 5 meters? It does the calculation for me. It figures it out. Every single box on the spreadsheet updated itself instantly. I could go in there again, change that 5 to a 10. An object will fall 10 meters in approximately a little bit less than 1.5 seconds. Questions, comments? Is it making sense? Have we all been able to kind of follow along with the steps that we're doing here?
Yeah.
All right. So now what I want to do is figure out how fast is it going at each one of these times. So let's figure out its velocity. Okay, and this is meters per second. Meters per second. And we'll say V for velocity. And this, I guess, is not just velocity, but this is velocity final, right? Because this is the velocity. I mean, I'm saying final because it's not the starting velocity. This is the velocity at the end of whatever time interval we're looking at. So V final after 0 seconds, well, this is the only one. I'm just going to say 0 because no time has passed yet. But how do we figure out how fast it's going at, some amount of time later? Well, we have a formula for V final. V final equals V initial plus AT. Oops. Guess V final. There we go. And so now if we do that calculation and we say equals, well, what's V initial? V initial is just the velocity that we typed in for time equals 0. So this is V initial, but it's always going to be that box. So again, we put $signs in there, D3, but it's going to be D3 for every single row of this. Our initial velocity doesn't change. Okay. Plus A, we click in the A column, acceleration column, and T times T. So we have to make sure we put our multiplication sign in, and then we touch our time. So let's see what this comes out to. wow, in 0.1 second, we're headed down less than 1 meter per second. Makes sense? The negative is telling us it's down, and we can drag this, highlight this whole column, autofill, and now it's telling us all these different velocities. All of them are down, which is good. That makes sense. Now, in our calculation over here, we had something for our V initial. I'm going to double click on this. You guys can see what I'm doing. Remember, this is saying that our height is the displacement plus our starting height. So in my parentheses, I have VIT plus 1/2 AT squared. So I typed in our V initial, but actually, instead of typing 0, I'm going to use our V initial from the spreadsheet. I'm going to use D3. And this is always our initial. I'm going to put a $sign. And now, when I hit enter here, nothing should change, but all of these still just have zeros in there. I don't want them to have zeros, so actually I'm going to remove those. Actually, I think I can highlight and just touch delete. There we go. Now I'm going to take this and fill it down so that my V initial is part of the formula. If I look at any one of these, it has inside the brackets V initial times T, right? V initial D, cell D3 is in there. So that means that I get to say, you know what? I can actually change this number. I can change this to being, what if I gave it a starting velocity in the upward direction, 5 meters per second? Instead of having a 0 in there, I can just change that from 0 to 5. And look, my whole spreadsheet updates itself. Let's see if this makes sense. If I started at 10 meters, when I start with a 5 meter per second velocity, I head up, I'm getting larger and larger. And somewhere in here, let's see, 11.21, 11.27, 11.23. Right in here, I've reached my maximum height. And now I'm starting to go down. And that's exactly what we would expect. So we've actually made a really powerful calculator where we're allowed to change our top columns. Let's kind of, I could change my starting height. I can change my starting velocity, and it can calculate both my position and my velocity at any time. We could take this one step farther and say, well, instead of just saying this is 9.81, what if we could type in a acceleration into this box? That would mean that we know acceleration never changes, but all of these boxes would have to be linked to the top box here. So instead of typing 9.8, 9.8, 9.8 all the time in this whole thing, notice my formulas are getting a little funny because I'm basically deleting the acceleration, saying there is no acceleration. That's not really what we want. We want to make sure we have an acceleration in here. And this should be always equal to the top number in this column. So I always want everything in the column C to equal cell C3. So if I put a $sign in front of C and a $sign in front of 3, that means that I can change that top number, and we can figure out what our position or our height and what our velocity would be, even on different planets with different accelerations. So I want to fix this really quick. I'm going to say, we're going to say this was our height equals our starting position. So I'm going to say, let's call it height initial plus all of that displacement calculation, just for so that we know what's going on and where this formula is coming from. If you ever want to make a column a little bit wider, all you have to do is kind of click and drag it out. Now we can see the whole formula. And now, I don't know off the top of my head, I'm going to have to Google this really quick. Acceleration due to gravity on the moon. Let's see what Google tells me. It is 1.62 meters per second. So nice in this column, if I just say negative 1.62 and hit enter, I've just updated all of my numbers. And we can see if I drop something from 10 meters, it's not even close to the ground yet on the moon. This actually, we threw it upwards. So it's actually still traveling upwards. It hasn't even stopped yet. Let's see if we give it no velocity to start and I just let it go. It's still not even close to the ground. We're still only falling 3 meters so far in 2 seconds. So that just kind of shows how slow gravity is on the moon. But hopefully you guys got a little insight on how these spreadsheets become super powerful and you can do really complex calculations in a relatively short amount of time without having to pick up your calculator at all.
Hey, Mr. Ronnie.
See you guys later.
Thank you.
I will post.
Thank you. Have a good one.
You're all gonna have to create basically what I just created here. So the video will be up and then there'll be a place where you can turn in this assignment. Have a good one. We drop tomorrow, so I won't see you until we're back here in person. Bye, guys.
Thank you.
All right, see you later.
You're gonna upload this, right?
Yep, I'm stopping the recording right now and then I'm gonna upload it.
Thank you. All right,
You
goodbye.
got it.
Have a good one.
All right, see ya. Bye.